In this video, I'll review factoring of quadratic expressions. So our first quadratic expression is x squared minus 8x minus 48. And we know that in order to get this kind of trinomial, we probably multiply two binomials, right? X plus or minus something times x plus or minus something. So in class, we used a box to help us understand what happened. How did we get this product? Well, we had x squared in here. Okay, that's the first term is x squared, and that came from multiplying x times x. And then we have the negative 48 right here, and that came from multiplying two whole numbers. And then we have this negative 8x. This term is what we get when we combine whatever was over here with whatever was over here. So now we need to think of two numbers that we multiply to get negative 48, but when we add them, because those are going to be our x terms, so when we combine those two terms, we get negative 8. So if I think of factors of negative 48, there's 6 times 8. One could be negative, or the other could be negative. 4 times 12 could be negative 4, or 4 and negative 12. Let's look at those options. There are more options, but I'll stop there for now. Let's see, do any of them add up to negative 8? Well, yes, 4 and negative 12 add up to negative 8. So that's a good option. So we're going to use 4. 4 times x is 4x. And negative 12 times x is negative 12x. And if you think of combining those two, it will get us back to this negative 8x that was in our question. So we have the right things filled out inside our box. And if we were asked to factor, then the outsides would represent the answer. So x minus 12 is what we got right here. And x plus 4 is our second factor. Okay, so those are the two factors that are equivalent to the product x squared minus 8x minus 48. The next problem is 9x squared minus 64, and hopefully some of you recognize that this is a special case. It is the difference of two perfect squares. We are subtracting two perfect squares. Let's see how that will look when we get the factors. So 3x times 3x are the same thing, right? We multiply it to get 9x squared, and that's what makes 9x squared a perfect square, because we can take the same thing, multiply by itself to get 9x squared. So 3x times 3x is 9x squared. Then down here we'll put negative 64. 8 times 8 is 64, but if it's negative 64, one of those has to be negative. So we'll make it 3x minus 8 and 3x plus 8. Why does this make sense? Well, if we think about multiplying the outsides, 8 times 3x, we had 24x here. Negative 8 times 3x is negative 24x. So these two terms made a zero pair, and that's why in our question on top, we don't have an x term in between those two terms because they were 0. It was 0x, so we don't have to write that. Okay, so the insides of this box are equivalent to our question, 9x squared minus 64. So now we could write the outsides, the factors, 3x minus 8 and 3x plus 8. Those are the two factors that multiply together to get 9x squared minus 64. Third question, factoring once again. We could draw the box. If you know this without the box, go ahead and do it without the box and just write your answer and skip ahead and see if you got the right answer. Okay, so we have our x squared term up in the top left bottom up box and 81 in the bottom right. And we know x times x make x squared. And then we're thinking of two numbers that multiply to 81. And when we add them up, they're going to have to add up to negative 18. So if you think of factors of 81, there's 9 times 9, okay? However, we need negative 18, right? So we're going to use negative 9 and negative 9. Negative times negative multiplies to a positive, so that works with a positive 81. And that gives us the terms negative 9x and negative 9x. And if you add those two terms together, yes, you get that negative 18x that we had in the product we were given. So we have this done correctly. So we'll write out the factors, x minus 9 and x minus 9. And if you notice, this is what we call a perfect square because both factors are the same. If you're multiplying something by itself, that's a perfect square. We could rewrite it as x minus 9 to the second power, x minus 9 squared. So that was actually a perfect square problem that we were given. Hopefully some of you saw that right away and just got right to that x minus 9 squared. Okay, fourth problem, last factoring problem that we'll do in this video, x to the fourth power minus 16. So this looks a little bit different than the others because it's the fourth power. But we still could use the same rules because if you notice, x to the fourth power is a perfect square and 16 is a perfect square, and we're subtracting them. We know how to factor difference of two perfect squares. So let's see how that works. We put x to the fourth power in here. X to the fourth power is a perfect square, x squared times x squared. And we put negative 16 down here. 16 is a perfect square, 4 times 4, but since it's negative, we need one negative, one positive, okay? And these boxes, again, would make a zero pair, just like we had in that other problem, question 2 in this video, that it was a difference of two perfect squares, right? So 4x squared and negative 4x squared are a zero pair. They add up to 0. That's why the question doesn't have that x squared pair. It just has the x to the fourth power minus 16. So what are the outsides we got? We got x squared minus 4 and x squared plus 4. Okay, now if you notice, x squared minus 4 is actually another difference of two perfect squares. So we're going to get x plus 2 times x minus 2, and then keep the x squared plus 4. As long as you know this step, you're good for my test. This step is just doing the same thing again. If you want to double check it with the box and make sure you understand why I got that, feel free to do that. I'm not going to elaborate in this video.